example 7 through example 10, i.e. through the end of this section, you are going to need to have your z-table handy. Friendly reminder that that is Appendix A in your textbook. So cholesterol levels in men 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. What's the percentile for a 20-year-old man with a cholesterol level of 190? So for this, we're going to have to calculate a z-score. Remember, a z-score is our data value minus our mean over our standard deviation. So I'm going to have 190 minus 178 over 41, which gives me 0.32. Note, this is not my percentile. I now take my z-score to the z-table, and I find the z-table value for 0.32. So I go to the positive, which would be the second page of our z-table, and I go to 0.3, and I go over to 0.02, and I find a z-table value of 0.6255. So that would mean that 62.55% of men between 18 and 24 have cholesterol less than 190. So this would mark, let's say, the 60, we want to round up, 63rd percentile. It's important to be able to convert between the decimal, which tells us the area under the curve, under our normal curve, the percentage, and the percentile. It's important to be able to go between all three. Let's take a look at another example using our z-table. What cholesterol level corresponds to the 90th percentile, the level at which treatment may be necessary? So what I need to do is I need to look up 0.90 in the z-table. Now we're not going to be able to find 0.90 exactly, but let's get really, really close as possible. So as I scour the z-score table, I find a value of 0.8997 or 0.9015. I think 0.8997 is the closest to, bless you, Bobby, bless you, closest to 0.990, and 0.8997 has a z-score value of 1.28. So go look in your z-table and look up 1.28 and you'll see this value. Now we're going to work backwards. I know that my z-score equals my data value minus my mean over standard deviation. So I'm going to substitute in. I've got my z-score of 1.28 equals x minus my mean all over my standard deviation. Now is when we use our algebra skills. So I'm going to go ahead and multiply both sides by 41. That's going to give me 52.48 equals x minus 178. Then I add 178 to both sides, and I get 230.48 equals x. So that's the cholesterol level that corresponds to the 90th percentile. The issue is cholesterol levels are only measured in whole numbers, so we're going to round that to 230. So a 230 cholesterol level marks the 90th percentile. Cholesterol levels in men 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. Okay, so it stayed the same. What is the percentage of men at this age range that have a cholesterol level of 188 or lower? That's our first question. The second question is, what is the percentage of men in this age range that have a cholesterol level of 188 or higher? So first thing we need to do is find a z-score for 188. So I take 188 minus our mean over our standard deviation. So I have 10 over 41, which is 0.24. So I go to 0.24 in the z-table, and I find that 0.24 has a value of a z-table value of 0.5948. So we could round that to 59%. So 59% have a cholesterol level of 188 or lower. Then what if I want to know 188 or higher? Well, remember, the area under a normal curve adds up to 1. At 188, we had 0.5948. So the area over here has to be 1 minus 0.5948, which is about 4.4052, which is, we could write as a percentage of 41%, because 59 at 41% add up to 100. So 41% have a cholesterol level of 188 or higher, while 59% have a cholesterol rate of 188 or lower. Last question. What is the percentage of men in this age range that have a cholesterol level between 188 and 192? So now I'm trying to find those between 188 and 192. Well, I know the area over here is 0.5948. And if I find the z-score for 0.192, I'm going to get all of this area in green. And then if I subtract them both, I can figure out what's left. So let's first find the z-score for 192. So 192 minus 178 over 41 equals 0.34. I find a z-table value of 0.6331. So that means the area in green is 0.6331. So if I take 0.6331 minus what's in blue, 0.5948, that's going to give me our orange, which is, of course I didn't do the calculation in advance. Of course not. Well, you guys can do some math with me. So we're going to take 0.6331 minus 0.5948, and we find 0.0383. If I multiply that by 100 to get a percentage, we get 3.83%. So we'll say about 4% of men have a cholesterol level between 188 and 192.